So today's lesson, ratios and proportions. This looks like kind of a throwback to maybe like Math 7 or Math 6, whatever it was that you took. But we need this because we're kind of pretty much finished the part on triangle congruence. And we're going to be looking at another way to compare triangles, which is through similarity. So we need to understand our ratios and proportions again. So we're going to do a bit of review here. So let's see how much you remember. Again, this part not on your paper. Ratio. Do you remember what a ratio is? What's a ratio, Amanda?
It's a comparison of one amount of items to another. Like, for example, the ratio of autistic boys to autistic girls is 5 to 1.
Okay, that's an interesting ratio. But yes, it's exactly what it is. We're comparing two things. So it is the comparisons of two numbers using division. To write ratios, we have a few different ways. We can say the words A to B. We can use this little colon to mean A to B, or we can write it as a fraction, A over B, which means B can't be 0. Why can't B be 0? Can't divide by 0. So an ratio, I guess, doesn't make sense to have something compared to 0. So that really doesn't make sense anyway. We always write them in simplest form. So let's take a quick ratio. Now, Amanda gave us a really good example. We're going to do one in here. I want to do the ratio of the number of boys to girls in this room right now. Boys to girls. So start counting. So what do we got here?
Would be 8 to 7.
Oh, we got more girls now, don't we?
1, 2, 3, 4, 5, 6, 7, 8.
8, 9, 10. We count. Absolutely count.
But you are women, not girls.
We count. That's it. I get to make the call. Now, 8 to 10. Can I leave it 8 to 10?
No, not really. It has to divide them both by 2.
Right. So, simplest form, we would say 4 to 5. We could also write it like this. Okay. So now let's say I want to do boys to the class. Boys to the class. 8 to 6. We're not going to count the teachers. So let's see. 8 to 16.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
The students. Yeah, let's do students. So isn't that right? And that's 1 to 2, or we can write that as 1 to 2. Look at that. What a nice ratio we have. So what's our girls to the class?
The same.
Look at this. It's so nicely balanced. We've got a very nicely balanced class here. It's the same
if you
ratio.
don't count the adults, but then
We don't
they're
count the
girls,
adults.
they're women's. No, women. Because women's is not a word.
True. Okay, so ratio, you know what that is. That's good. The other examples, we've got of ratios now, going back to kind of the math-related ratio. The ratio of a side length in triangle ABC to a side length in triangle DEF. Raise your hand if you think you know what that ratio would be. Side length in the first triangle to a side length in the second. Hilly, did you know? I thought so. They can go up and then went down. I want to go from triangle ABC to triangle DEF. 2 to 1. So again, we can write that as 2 to 1. I can also write it as 2 to 1.
Would that be wrong if you got the order wrong?
Well, kind of, yeah. So the order actually matters. Which way does that ratio go? Because it gives us information that the bigger triangle has bigger sides compared to the smaller triangle. So it makes sense. So it does actually, you have to kind of be aware of order. So excellent question. Excellent question. The ratio of width to length in this quadrilateral RSTU, width to length. Which one's width and which one's length? What do you think, Amanda?
1 to 2.
Okay, 1 to 2. Explain why.
Because, because the shorter side is width and longer side is the length. And that would be 7 to 14 at first, but then we can divide to 1 to 2.
Good. Good. That's exactly correct. And let's see what we got. Always put the ratios in the simplest form. So we always have to do that. Should be an automatic. What I don't want to do, so it gets back to something you asked before. Can I use decimals? In general, we don't use decimals when we're talking about ratios. Not like you can't. You could. And very often we'll turn them into percents, things like that. But if you're doing straight ratio, it's much easier working with the fraction. Yeah. What? They don't have a weight? Sure they do. They don't have a height.
It depends on how you're looking at it.
Right, I've got two dimensions. Joseph, I have two dimensions. One of them's length, one of them's width. What it's missing is a height, that third dimension. Okay. Extended ratios. Now, we were talking about ratios, something to something. Two things, right? We can have more than that. So we can compare more than two numbers. And here's the example of a ratio the size of a triangle. 4 to 5 to 8. Yeah. So let's see. We can find the length of the sides of a triangle with side length ratio 4 to 5 to 8 if the perimeter of the triangle is 204. So they're giving us some information here. I like to underline the important bits here. So what you do is you draw a triangle. And then what does that mean to have that ratio? It means that if the sides were all divided by the same number, you would be left with 4, 5, and 8. And what's that number you would divide by? I don't know. So what did I call it? X. So 4x, 5x, 8x, you divide it by that x number, there's your ratio. So how am I going to find x? I have more information. Perimeter is 204. So if I add up all these sides, I'm going to get 204. So what have I got here? 4 plus 5, 9, 17x is 204. And now let's see, I didn't do that in my head. So I want this on paper, so I have to think about it. Who's got the calculator? Yeah, what'd you get, Abby? 12.
I figured it out without a calculator.
Okay, so good. X is 12. Now find the length of the sides, so you just kind of work it out. 4 times 12, I know what that one is. 8 times 12, well, I guess that's going to be double this, right? So 96. And then 5 times 12 is 60. So I can find that. So when you see extended ratios, you kind of draw that picture and kind of work it out that way. That's what you're doing with extended ratio. Proportions are another thing that you should already know about. So they compare two ratios. Okay, so I'm comparing two ratios, and generally we write them in fraction form, but you can write them also as two ratios like this. And we have means and we have extremes, and I doubt your Math 6 teacher kind of talked about means and extremes. They did? Oh.
They talk about it in the algebra.
Okay, well that's good.
Like the mean is the average.
Right, yeah, let me get to no, I'm talking about a different word meaning of the word
Oh.
mean. So when you're looking at a proportion, and actually it's easier to see it if you write it as A to B equals C to D. I can remember the extremes being the things that are farthest away. So the A and the D are what we call extremes. And the other one is called the mean. So I'll use a different color for these. The inside ones, those are called the mean. And, oops, let me do that. So if you know this vocabulary, I remember learning this, but I don't know who else is old enough to remember this. They used to say the product of the means equals the product of the extremes. Remember that at all? She's like,
That does not make sense.
Okay, could have been.
Right.
It could have been. We used to be told, remember, the product of the means equals the product of the extremes. And that was another way of saying the cross-product property. So let's see why that is. So here are my means, B and C, and here are my extremes. This times this equals that times that. Okay? So this is our cross-product property. This we should have had in algebra, right? So I remember this from algebra.
No, we were
Those
just
research
told,
students better be raising their hands. Well, yes, she's having math class, of course.
my math class was just told cross multiplying it magically works.
Well, we're going to talk about why it magically works in a minute. So the cross-product property states, in a proportion, the product of the extremes equals the product of the means, or if A over B equals C over D, where again, B and D are not zero, we need to specify that, where we understand we can't divide by zero, then A times D equals B times C. Okay, product, that's a cross product. And I don't want it to be magic anymore. So how come that works? You raise a very good point, it just magically works. So I am gonna first apply, what property says I can multiply the same thing on both sides? That's using the fact, right? Yeah? Multiplication property of equality. So I'm doing that. So I'm justifying my steps. This cancels out. And now I've got A equals, I'm just going to put the B in front, B times C over D. I'm going to apply it again. Multiplication property of equality. It says I can multiply the same thing on both sides. They're still going to be equal. D times A is the same as A times D using commutative property of multiplication. This will cancel out. And here it is. So it's not magic. It really is. We're just kind of, getting rid of denominators. Yeah.
Actually, B and D, B equals 0, it'll still work, but you just have non-existent fractions.
Well, I can't ever make it be B and D. I can't even do a what if, because I cannot put a fraction over 0. It's just completely undefined, even in that what if scenario. Yeah.
Couldn't you just memorize A, B,
You sure could. But what's nice, if you know where it comes from, if for some reason you can't remember, you can always get it back. Okay? Yes?
Everything that we learned before, is it going to turn into either a property theorem or postulate?
Everything? I don't know. Maybe. It should. Okay, so let's look at examples. This one is on your paper. So let's do some examples. So this is example A on the paper. The perimeter of a rectangle is 484. So now that's perimeter. The ratio of length to width is 9 to 2. So there's where the order, which Keely had a good point. So the longer side to the shorter side, right? One's longer than the other. Find the area. Oh, wait a second. Find the area. So let's kind of take this step by step. You have to kind of draw the picture. Just hang on a second. You have to draw the picture if it's not presented. And kind of lay out what I know. I don't know these values, but I know it's in a ratio of 9 to 2, length to width, which means if I divide them both by the same number, I get 9 and 2. So what number? I'm just going to put X because I don't know what that number is. Is this a question, or are you just going to give me a number? I don't want an answer.
No, it's just funny because, the funny thing is that, it asks for the perimeter on the paper, again, even though it says find the area.
Is there a typo on here? What? No, wait, we're working it out. Hang on. No, it's not, you have to find the perimeter kind of first. So why that blank is there is because I need to know, do you know the formula for perimeter? That's why it's there. How do you find the formula for perimeter? Keely? Yeah, length plus width plus length plus width. So why don't we write that as L plus L is 2L, and W plus W is 2W. So that's how you find the perimeter, and that's what I want you to put on that line there, okay? So I have to know that formula. So now I can kind of substitute in. So the perimeter for this one is 484, and it's twice the length, which in this case it's 9x, plus twice the width, and our width is 2x, right? I don't know what the x's are yet, but this is a solvable equation. So 484 is 18x plus 4x. So 484 is 22x. I'm going to divide both sides by 22. When I did that, you tell me what you get, see if you agree. What did you get, Josie? 22. Is 484 divided by 20? You have your calculator, just verify we're doing this right. I know what x is. Yeah, we agreeing? Okay. So that means I can find this. 2x is 2 times 22. So this side is 44. And this side is 9 times 22. Oh, I did work that one out. 9 times 22 was, I don't know what it is. I thought I wrote it down. What's 9 times 22? 198? Okay. So now I want to find area. The area is length times width, right? So I know I've got numbers now. I've got 198 times 44. And I hope we all get the same number. If you got a calculator, figure it out with me, because this is what I got. 8,712, whatever these units are, square units. Now you got, so Remember, area is square units, perimeter would be units, whatever they are, feet, centimeters, inches,
How long?
or that. Okay, so sometimes these are multi-step, you gotta work around them. Yeah.
When there isn't a unit, do you just put units first?
That's what I would do. It just says you're thinking, always thinking about what the units are. And they didn't tell us, so I'm just gonna say whatever they are.
Or
Square
you
units.
could just put U squared.
Okay. All right, now let's look at example B. The measure of the angles of a triangle are in an extended ratio of 1 to 2 to 3. Find the measures of the angles. So when you get questions like this, draw a triangle, and again, it means that this ratio means if you divide the sides by the same number, you're going to get 1, 2, 3, if you put it in the simplest form. I don't know what that number is, so I'm just going to make it x. So 1x is just an x, 2x, 3x. How will I find the measure of these angles? How will I do that?
Automatically.
How do I do this, Joseph? Yes. Triangle sum theorem says if you add up all the angles, you're going to get 180 degrees. So let's add them up. 1x plus 2x, 3x's, 3 more x's, 6x's, and that's going to be 180. Divide both sides by 6. X is 30. Let's see, what is the question asking? Find the measures of the angles. So this angle being x degrees is 30. This one is 2 times 30, my x, so it's 60. And this one is 3 times 30, so it's 90. So I found all the angles. 30 degrees, 60 degrees, and 90 degrees. Okay, so an extended ratio, don't be afraid of them. Draw a picture, put that little x to stand for the number that they all have in common as a common factor, and just work it out. Okay. Let's see, we're solving proportions here using that cross product property. So this times this equals that times that. So 10 times x equals 5 times 16. That's the cross product property. So 10 times x equals 80. Okay, 5 times 16. Divide both sides by 10. X equals 8. You can check your work. If you put an 8 in here, you can use the calculator to do 5 divided by 10, 8 divided by 16, or you hopefully can both see 5 over 10 is a half, and 8 over 16 is also a half, so I know that's the right answer. Uh-oh. What if you have a binomial or some other polynomial in either the numerator or the denominator? Evan? Well, sort of. You're on the right track. You know something else has to happen. If you want to multiply by y, that confuses this guy. I think the cross product property will be the easiest way to kind of deal with this. So I still want to take the cross product. This times this equals that times that. The thing to remember is that with fractions, there's an implied grouping. Implied grouping. An explicit grouping would be if they put in the parentheses. They're there. So it might be very good practice or a good habit to get into is if there's a polynomial in either the numerator or the denominator, put it in parentheses. So that when you take your cross product, 3y times 1 equals 2 times this thing, make sure you have grouped this, because this is different from this. Do we agree? Yeah, we don't want that. It's 2 times the whole thing. So we can distribute that 2. See, that's different from that. And now subtract that to y equals 2. I do like to check them. That would be y over 2 plus 1. And this would be a 2 over 3 times 2 is 6. Well, 2 over 6 is 1/3. So I just like to get that little peace of mind just to make sure I did it right. Plug it in and check it. Why not? It takes a second. If you really don't like doing that, you can just put it in your calculator. 1 divided by 3, 2 divided by 6, it's the same thing. All right. Okay, this should be new. I don't think you guys know about geometric mean. Anybody heard about geometric mean before?
Yeah.
Heard of it. Don't know what it is. Okay, good. It's fun to do something new. But you know what? An arithmetic sequence. I believe you guys have seen those. I think you have. And she says, yes, I have. So, like, yeah. We kind of did this when we started our logic unit. So, 2, 5, 8, 11. What do you think comes next? Why? Plus 3. We look for a common difference. The difference between 5 and 2 is 3. Now we also have geometric sequences. Let's see if we can figure out what comes next. 2 to 6, 6 to 18, 18 to 54. Whatever 54 times 3 is, and it's 162. And so what is the common factor? Meaning, what did I multiply? 3. And so our next number in the sequence will be whatever 162 times 3 is. So we have a common factor of 3. So an arithmetic sequence and a geometric sequence are different. One adds the same number, and one multiplies the same number. Yes, sir? The number is, it's possible. I suppose it's possible. Our inductive reasoning says if you're adding 3 every time, probably not. Right? But I guess you can say anything. You can make a case for anything being the next number. But if you tell me it's an arithmetic sequence, now I have a rule that I'm adding 3. If you tell me it's a geometric sequence with a common factor of 3, now I have that rule. So I don't think we're going to be out of sequence if I'm following that rule. Okay, so what does a geometric mean? Well, let's go back a second. What's an arithmetic mean? And this, I think you answered this a moment ago, Amanda. Arithmetic mean. What's an arithmetic mean?
Me, I didn't.
Yeah, you did.
I did?
You don't even remember, but you did.
Oh yeah, like the arithmetic mean would mean that you add up all the numbers. Funny that if once you take a set of numbers, add them all up, and divide them by the amount of numbers in the set.
Yeah, it's an average, right? What we call an average. So I can take an arithmetic mean. Well, there's geometric means too. So now we have to figure out what that means. So it's a term between 2 terms of a geometric sequence. Okay, and just to kind of compare it, if I can say the same thing for an arithmetic one. The term in between 2 of them, I'm not saying this well. You have an arithmetic sequence. You pick 3 numbers. The one in between is the arithmetic mean, isn't it? What's 2 plus 8? Divide by 2. 5. Look at it, it's true for all of them. So if you look at the 5 and the 11, add them up, divide by 2, you get an 8. Because that's 16 divided by 2 is 8. So it is, it's the average. The one in between is the average of the 2 numbers around it. Or you could call it the arithmetic mean of the 2 numbers around it. So a geometric mean is that same sort of idea, except now that we're multiplying, it's a little bit different. So this is the geometric mean. So the number between 4 and 100 in a geometric sequence will be 20. Okay, so how do you find one? So if I have a sequence, geometric now, 3 something 300, I have to figure out what that number is in between. How'd you do that?
Because 3 times 10 equals 30, 30 times 10 equals 300.
Okay, how'd you get there? Just kind of thought about it, popped in. Yeah?
I think it's like you have to see what you have to multiply to get 3 to 300 and then divide that by 2.
Okay, there's something going on with the 3 and the 300. You're so on the right track. You're so on the right track. Let's see if we can kind of figure it out.
Divide it by
Yeah.
the way you divide it.
Let's figure it out. I have a geometric sequence, and we're going to use just, it's A and B. I want to find out what goes in here. There's some value, let's call it X. Now, how do you get there? Well, let's see. What does a geometric mean? It means that if you divide X over A, you get some number, right? If you divide B over X, don't you get the same number? Isn't that how geometric mean works? So X over A is the same as B over X. I can set up a proportion. Let's see if I can solve this proportion. So I'm going to use a cross product. X times X, X squared. B times A, AB. X squared equals AB. Now how do I get X by itself? We'll take the square root of both sides. So X is the square root of AB. Wait a second, does that work? So if that says you could take the square root of this product, 3 times 300. That's the square root of 900. What's the square root of 900? 30. Oh. So look what we do here. I think this is cool. To find an arithmetic mean, you add and divide by 2. To find the geometric mean, you multiply and take a square root. Ooh, yeah.
So now
very close to what a geometric mean does, the general rule. Yes? First question.
What if there are
No, you guys are asking an excellent question. I'm going to answer that in a second. What was your second question?
do we have to live more than like
It's always worried about it. Come on, what are we in for? Wait and see. Let them be surprised.
Fibonacci mean.
Amanda, you have a question?
Yeah, so you're finding the geometric mean of three numbers. Once you multiply them, do you find the cubic root of them?
You guys are really smart. Let's see. Let's compare, right? Let's sneak peek into future math here. Now, arithmetic mean. This was, remember this terminology?
Yeah.
Summation,
Yeah.
I goes from 1 to n. Some people are shaking their heads. No, not this.
I don't like
right?
this.
Of x sub I divide by n. What does this mean? This means you're adding a bunch of numbers, right? No, you're just adding n numbers. 4, dot, dot, dot. All the way, you add up n numbers. That's what this means. And then you divide by the numbers you have.
Sigma makes sense.
That's how we find what we tend to call this the average, even though we have other averages, right? Add up the numbers. So when you're finding a geometric mean, then you got a new symbol here. This is an uppercase sigma. This is an uppercase pi. Uppercase sigma means add. Uppercase pi means multiply. So this says multiply a bunch of numbers, n numbers, and then take its nth root. So yes, you're right. If you want 3 numbers, multiply the 3 numbers, take the cube root. If you have 5 numbers, multiply the 5 numbers, take the 5th root. Now we're only working with 2 numbers, so if you're going to take 2 numbers geometric mean, you multiply the numbers and take a square root. So yeah, a little sneak peek into the future. I think it's cool. Question? Amanda?
So basically, it's that summation thing. The summation is a lot like the for loop, right? Because it's like for, like in Java or C++, basically you specify a number to start out.
Yes, it is like a loop.
0 or maybe 1, and then you set like
This is a loop with added?
to do it with less than 5, and you just take the numbers and then write add them
Yes,
together.
and this is a
And
loop
like
with
the second
multiply.
time, write that in Java.
You could absolutely write these up. You can go these up. Yes.
I was trying pi, you mean like the second pi?
Uppercase pi. Lowercase pi, we know what that is, right? We can't use that one. Lowercase pi is.
Is that the uppercase of the people?
No, it's pi. Uppercase pi. You know how lowercase sigma is something else? And lowercase pi is something else?
Is that pi?
Yeah, no, it's the Greek alphabet. Uppercase pi, if you're using it in math, you're multiplying stuff. If you're using it lowercase, you're working with, the ratio of, circle diameter, that kind of thing. Okay, so sneak peek. So, by seeing that, hopefully that remembers, if you're taking geometric mean, how does it work? If I want the geometric mean of 2 and 8, and let's see, I'm on the back here, page 2, first example. If I want to find the geometric mean, you multiply the 2 numbers, and you take its square root. So this becomes 2 times 8 is 16, 4. And does that work? Right? Times 2 times 2. So it has a common factor of 2. Now what about geometric mean of 24 and 48? You multiply the numbers and you take the square root. Now this one, wow, it becomes like this really big number. It's easier to not do it that way. So let's see, how can I do this in an easier way? I see this as being 24 times 2. Right? Is this the same as that? What's the square root of 24 times 24? 24. So that is the geometric mean. You mean it's numbers a whole number?
Yep.
What?
Kind of a problem that just makes finding
Well, that's good. That's what you should ask. If it's not clear from the question, then you need to get further clarification. This one tells us find the geometric mean, so we know what to do. But if it doesn't say, then you need further clarification. My guess is, depending on what you're doing, you probably need arithmetic mean. But get clarification if it's not clear. All right? Geometric mean. Now I'm leaving this for a while. This will be back. So, we're going to learn it, and then it disappears, but it will be back. So don't put it out of your mind if it seems like we're like just, okay, it's gone. All right. Other proportion properties that we need to know about. Given a proportion, A over B equals C over D, There's other things we can do. Now, if you take the reciprocals of both, you still have a proportion. So turn it upside down, B over A and D over C will be a true proportion. You can do that and still have a proportion. Okay? You can also interchange the means. These are the means. So if I put the B up here and the C down there, that's what I did here, I switched them, you still have a true proportion. It still works. And even though for some reason they don't want us knowing this rule, you can also exchange the extremes if you wanted to. So I could say D over B equals C over A. That's kind of a similar idea to this. You can switch them, it still works. This one's a really kind of cool one. A plus B over B equals C plus D over D. You add the numerator to the numerator the value of the denominator. In both of them, it still works. And why is that? I'm going to try to separate this out. That's A over B plus B over D, right? And that's C over D plus D over D, correct? What's the value of B over D? 1. And then what's the value of D over D? 1. I added 1 to both sides. Who says I can add 1 to both sides? Addition property of equality. So I can. So if you see this works too. Yes? Huh? Hey, you can't talk loud. Can't hear you. Yeah, but it's just saying you can set up a proportion. If for some reason it's helpful to do this, you can. It's equivalent. How do you know these work? Here's the simplest way to know if you've got like an equivalent proportion. A times D equals B times C, right? That's the cross product. What's the cross product here? A times D equals B times C. What's the cross product here? A times D equals B times C. So you can kind of swap these around, no problem. If you did the same thing here, oh gosh, I hope this works. Wouldn't that be funny? So let's see, I've got AD plus BD equals BC plus BD. Subtract out the BD's, AD equals BC. So if you want to know if you have an equivalent proportion, take the cross product and compare it. So looking at just some examples here, we're kind of in the middle of page 2. If A over X equals B over 5, then A over B is what? So what happened here? I moved the B here. So what should get moved up above there? The X, right? So this should be X over 5. A over B is X over 5. Check it by taking cross products. 5A is BX, 5A is BX. Yeah? No, they just wanted you to get equivalent proportions. This will become useful soon. That's why we're doing it. Probably why, who cares? We may need to do this in the future, and yeah, we will. So let's see what's going on here. X over 3 equals 9 over Y. So if I add the denominator to this one, what's an equivalent for the other side? Yeah, this is, you can just add the denominator value there. Right? Yeah, that's this one. That's this one down here. If you add the denominator in, it still works. Yes? I have to add this denominator because remember I'm adding 1.
Yeah.
So I want to add Y plus Y.
Okay.
So that's why it becomes a Y. True or false? Now the true or false is the easiest way is to take cross products. 7 times X is 10 times Y. Does this have the same cross product? Yes. If it does, true. If it doesn't, no. And what they did here, I believe, was they took, flipped them, they're reciprocals. True or false? If X over Y equals 10 over 7, is it true that 7 over X equals Y over 10? Just what do you think? Why? Yeah, I need to speak loud. I can barely hear you.
The other one is 70 equals X1.
Take the cross products. 7 times X is 10 times Y. Let's look at this one. You get XY equals 7 times 10. Not the same thing. So you didn't create this proportion correctly. So if you want to know if you can rewrite a proportion a certain way, check it by taking cross products. Another couple of examples here. Using triangles now, we've got a few examples. In the diagram, now these are ratios. RU's value, its length, to US's value is equal to, is in proportion with RV to to the t. So you're going to set these up. RU, its value is 5. US, its x. RV, its value is 20. And VT is 8. Set up the proportion and solve. Take cross products, easiest way I think to deal with it. And then divide both sides by 20. So we found x. I have to read the question. You never know what they're going to ask, so I always go back here. They just want x. There it is. Okay? Let's look at this proportion. RU is to US as RV is to VT. And what do we got here? RU. Whoa. Okay, what is RU? RU is an x, is it? Yeah, exactly. So we have to think about it, like giving me the whole thing and a piece. So what's this going to be? Picture if that was a 10. This would be a 6, right? So if it's a number, I think you know exactly what to do. I don't know what it is, so it's x minus 4. So now RU is x minus 4. US is 4. RV is 3. And VT is 6. Cross product. Be careful, I've got a polynomial up there. I'm going to put it in a grouping so I remember to group. So 6 times this grouping of x minus 4 equals 4 times 3 is 12. You can distribute it. I think I'll divide both sides by 6 because it just looks like it'll be a little bit easier. So x minus 4 equals 2. So x equals 6. They just want me to find x. They could have said find RU. So read the question carefully, what they want you to find. Okay, a couple of other examples here. This is bottom of page 2. In the diagram, you've got this proportion, JM, these are lengths now. The length of JM to the length of ML equals the length of KN to the length of ML. So let's see what I got. JM. Again, JM, I have to kind of make a calculation for it in terms of x. So what would JM be? If you're having trouble with these, put a number here. Pretend this was 30, right? What would JM be? 20. How do you get there? What should this be? Yeah, Joseph? It's x minus 10. So if I want JM, that's x minus 10. ML is a 10. KN is 18. And ML is 15. Take the cross product, group this first. 15 times x minus 10 equals 10 times 18. I'm writing it this way so I can reduce this a little bit. If I divide both sides by 5, say, then I get 3 times x minus 10 equals 2 times 18. You don't have to do it this way. You can multiply it out. It's just how I think. Divide by 3. X minus 10 equals 2 times 6 is 12. Add 10. 22. You don't have to do it this way. You can distribute it out and multiply. That's perfectly fine. I'm used to not working with calculators. How we did stuff in the old days. Just reduce. X is 22. Now they're asking me to find JL. Well, JL is X. So I guess JL is 22. And what's JM? It's going to be 22 minus 10. I guess that one is 12. Yeah. Last one on this page here. This thing, I think you've done these. You've done these, definitely some kind of pre-algebra you've had. A highway map is 9 inches long. This is like scale drawings and stuff. So the actual highway is 36 miles long. And what's the scale of the map? So it goes 9 inches is to 36 miles. We tend to say 1 inch is what? So to get 1 inch, you would divide both of these by 9. So 1 inch is to 4 miles. So 1 inch to 4 miles. It works out nice here. It was a nice, integer answer. In generally speaking, though, even if this was like say a 38, you would divide. And I think this would be a good case where you could put a decimal. Yes, sir.
I did 1 inch equals 253,440 inches.
Why would you do that? Remember, scale drawing on a map is, if you're looking at a map, I'm thinking of practical use. I'm going to just be like smart here. But
No,
you don't want it. I would mark you wrong if you did that on a test, because I really want you to do the spirit of the question. How do you read a map? You're trying to figure out how far away things are in miles. Yes? If you did what? This either way is fine.
I started with the 9.
Yeah, you can work if you like the colon form. That's fine. Yeah, Kelly?
always divide by the numerator?
And generally speaking, usually say 1 inch is how many meters, generally speaking. Okay? Any questions?